Hello and welcome back. Another video, another logic game challenge, once again from Cat 23. But today our main agenda is the beauty and joy of problem solving. We've already looked at the easy doable sets and how to look for them and how just managing two sets is enough for the clearing the cutoff. But here I want to talk about how when you tackle a problem like this and struggle with it and then finally figure out that there is a great rush of dopamine in your system, and once you start enjoying that, then DILR becomes a fun activity, a joyous activity, something that you like and enjoy doing. The moment you hit that space, that you start enjoying the game, that is where a real growth or a exponential trajectory of growth happens. So I hope while solving such a problem and maybe even struggling with it for a day and then finding the solution, you experience that joy, because that can really get you hooked to these kind of problems, and because you will get that joy, you will want to do more of it, and the relationship with the problem will change. You will not be scared of it, you will look forward to it, right? So with that broad agenda, let's dive into the story and notice what the process is and how to figure out the process in a new challenging set as such, right? Obviously it is challenging only on the surface when you look at it from far away. The moment you start getting close to it, the logic, the formula, the thinking method will appear to you. So let's go step by step, dive into the story, and whatever important tips and pointers I have, I'll keep adding to the story. There are 9 boxes arranged in a 3 into 3 array as shown in tables 1 and tables 2. Table 1 and table 2. 3 into 3, 9 boxes are there, 9 boxes are great. Each box contains 3 sacks. Each sack has a certain number of coins between 1 and 9, both inclusive. I want to slow down with this part of the story and visualize it a little or try it out in one of the boxes. So for example, in my second column, first row, there are going to be 3 bags. This is not 0. This is a bag that has certain number of coins in it. And again, take an example. Maybe this particular bag has 3 coins, maybe this bag has 5 coins, and maybe this bag has 8 coins. Great. The moment I try out a simple number, I know the same story. 3 bags here, 3 bags here, 3 bags here, 3 bags here, and they will have a number of coins attached to each bag, right? So trying out one example can help you visualize the story better. Now I know the same story is going to repeat over and over again, but I don't need to read this sentence again. I'm very clear in terms of what this covers in the story. This tells me each box has 3 bags and each bag has a certain number of coins from 1 to 9, right? So easy so far. The average number of coins per sack in the boxes are all distinct integers. So first of all, average number of coins per sack, distinct and integers. Slow down and master this. Once again, creating an example will help a lot. I already took 3, 5 and 8 as my coin numbers. What will be the average number of coins per bag? How will you find that out? You will find the sum. You will say add all the coins divided by the number of bags. There are 3 bags. That means I will add this and divide it by 3. 8 plus 5, 13. 13 plus 3, 16. 16 divided by 3. Try the process out and you will see that I'm getting 5.33 something, which is not an integer. So I stay with this piece of information, and I'm sure anybody with any basic maths will figure out that okay, whatever the sum is of the 3 bag number of coins, it is going to be a multiple of 3. Because as I see in this example, if it is not a multiple of 3, when I divide it by 3, it will not be an integer. Because it is saying it is an integer, I know the sum is going to be a multiple of 3, right? That means in any of the other story, if there are 3 bags here, whatever is the number of coins in the story, when you add them up, it is going to be a multiple of 3, or it has to be divisible by 3 so that you get an integer, right? So can I have a 1, 1, 1? Yes, I can have a 1, 1, 1. But can I have a 1, 3 and 4 maybe? No, because 4 plus 3, 7 plus 1 gives me 8. This story will not work for me. This story can work for me. Once again, notice what I'm doing. I'm trying out very simple examples to better understand the process and get the whole impact of this rule going for me. So integers, average number of coins I've understood, but it also says distinct. What does that mean? The average number of coins in this box, in this box, in this box is all going to be different from each other. That means the sum in each box is going to be unique. It is going to be a multiple of 3 or divisible by 3, but for each box the sum is going to be different. Let's play with this a little more. We can have coins from 1 to 9 both inclusive. So maybe the minimum number of coins would be 1, 1, 1. Each bag has one coin only. And the maximum is going to be 9, 9, 9. The total here is going to be 3. The total here is going to be 27. This is a multiple of 3. This is a multiple of 3. This is my lowest limit. This is my highest limit. In between this story, any other multiple of 3 will also work. So I'm going from 3 to 27, but a sum of 6, right? Because you 6 divided by 3, the average will be 2, but the sum will be 6, the sum could be 9, the sum could be 12, the sum could be 15. These are all multiples of 3. And if I count them, I will see I'm getting 9 multiples. From 3 to 27, I'm getting 9 multiples. And now I have 9 boxes. So these multiples of 3 will go in as the overall sum of the 3 sacks, right? The story should be very, very clear. So I read this and I am also getting this, that okay, each box, the sum is going to be a multiple of 3 and each box is going to be distinct. I also know that the possibilities are between 3 to 27, all multiples included, right? Furthermore, the total number of coins in each row is the same. Each row. So if the sum here overall of this box plus this box plus this box is x, this would also be x and this would also be x. Furthermore, the total number of coins in each column is also the same. So if the sum of this column is y, the sum of this column is also going to be y, the sum of this column is also going to be y. But because of my previous figuring out that my stories are going to be essentially 3, 6, 9, 12, 15, 18, 21, 24, 27. These 9 numbers will go as the sum, right? The average can be found by dividing it by 3, but these 9 numbers will be the various sums. So I know if I want the sum of all 9 boxes, if I just add this up, I will get it, right? And what if I do a xxx, right? I add them up, 3x. This x contains all these 3 boxes, this x contains all 3 boxes, this x contains all 3 boxes. That means this 3x has contained the total sum of all the 9 boxes, right? That means 3x is equal to 3 plus 6 plus 9 plus 12. You figure this out, hit pause and try and solve this by yourself, whatever method necessary, and you will get the value of x as 45. You could have done the same story here, that y plus y plus y, the total is going to be the same thing, because these are the only possible situations for all the boxes, right? So you get the value of y also as 45. So you know the row sum is 45, 45, 45, and the column sum is also 45, 45, 45. Now, right now, I have fully juiced this rule out. I stayed with the rule and I extracted as much as I could from the story. But it is also possible that maybe you did not go into this much detail. You figured out the average coin story. You figured out that you noted that the row sum is going to be same, the column sum is going to be same. But maybe you did not figure out this 45 story. What I'm trying to say is that to get to this 45, there are other ways as well. So you don't necessarily have to follow this particular process. This is great. This is full, fantastic, systematically organized. But in fact, when I was first looking at the problem, I did not use this. This came later. I could figure out that the total is 45 from some other experimentation as well, which is an important point. That means as long as you're consistent and at the process, you're hitting the challenge one way or another, one direction or another, you will come to the final solution, right? And why is that? Because what happens sometimes is that you read it and then you read the next few rules also. You might not have paid full attention in the very first step, which is a great idea though. Actually, you just look at it, extract as much as you can before reading the rest of it. But most people tend to preview a little. So maybe you would have read the future conditions. There are more parts to the story. You would have read that earlier and figured this out later, which ordering is fine, right? Let me continue with the story. Furthermore, more data in the story. Table 1, this is the first table, gives information regarding the median of the number of coins in the 3 sacks in a box for some of the boxes. So once again, let me try out an example. If a particular box, let's say, has 5, 9 and 7 coins in the 3 bags, to find the median, the first thing that you have to do is organize it in ascending or descending order. So the organized order would be 5, 7, 9 in order of size. And now my median is the middle term. That means if you have any set of data, you organize it in increasing or decreasing order, then you find the middle term. That middle term is the median. If you do not know what a median is and if you cannot figure it out right now, obviously this challenge is going to be very difficult. So I'm assuming that this much everybody can figure out, that the median is the middle term when the data is organized in ascending or descending order. Going back to the story, the first table, the number given is the medium. Now let me again immediately try the data out. In my second column, the 3 bags, the median is 9. That means the middle value is 9. Let's say if I'm arranging it in ascending order, small value, biggest value, you can't have a bigger value than 9, but the median is 9. That means the last value also has to be 9. Right, so great step. When I look at the median, at least with this 9, the figuring out the last step was very, very easy. And again, as of now, I'm not fully into the problem solving. I'm just reading the information and warming up my brain while with additionally looking at the data, so that this story and this story are matched together well in my head, right? Okay, so this is the median number. In table 2, each box has a number which represents the number of sacks in that box having more than 5 coins. Let me look at this story only. This box and this box correspond to each other, and here it says 2 and 1 star. This 2 means 2 of the bags are more than 5. That means this third bag has to be less than 5. Okay, easy enough so far. Furthermore, that number is followed by a star. Yes, I see there is a star here, and sometimes there is a 2 star. Followed by a star if the sacks in that box satisfy exactly one among the following 3 conditions. Then 3 conditions are given, and 2 stars if 2 conditions out of the 3 are being met. Now let me read the conditions as well. The minimum among the numbers of coins in the 3 sacks in the box is 1. The median of the number of coins in the 3 sacks is 1. The maximum among the number of coins in the 3 sacks is 9, right? So simplify the rule for yourself. Minimum is 1, median is 1, highest is 9. These are the 3 possible rules. This 1 star means one of the rules is true, right? Okay, let's again play with it once so that we figure out the process. And it's okay to take time in the beginning while you're figuring out the process, because once you figure it out that this is the direction of logic that I'm going to take, then solving the challenge or doing the final numbers and calculating is going to be very, very easy. That happens very, very quickly. So effort is always in a DILR set is in the beginning, and make sure that you're slow, steady and very clear in terms of how to play this game. Let me try this out. There is a 1 star here. One of the rules is being one of the conditions is being met in this story. Let me see this one. This is an easy one. The median of the number of coins in the 3 sacks is 1. I know the median is 9. So obviously this rule in this particular story, I'm looking at second column row 1, second column row 1. 9 is the median, 1 is not the median. This rule is definitely out. Furthermore, I already figured out that this is 9 and 9. The maximum among the number of coins in the sacks is 9. That means this rule is being tested. That means this rule is also out. Great. So 9 and 9, 18. And now I will go back to the story of my sum being a multiple of 3. 9, 9, 18. This number has to be less than 5. 5 or less than 5. Which number will give you a total sum which is a multiple of 3? After like hardly any effort, you will figure out that 9, 9, 18 plus 3 gives you 21, which is a multiple of 3. No other value. 1 will not work, 2 will not work, 4 will not work, 5 will not work. So you're only left with this. And great, just while trying it out, I figured out that these values are going to be 3, 9, 9. Right? Which should make me very happy, because I've already figured out one box. I've looked at the rules at least once and I'm kind of getting familiar with them. Minimum is 1, median is 1, or the maximum is 9. And how to test the rules as well, right? I looked at the rule and I saw whether this matches or not. The median is 1, median is 9, this rule is not there. Maximum is 9, this has to be the rule, this rule is not there. And then using the sum from the previous information that I gathered, I have nailed this down. I'm very, very happy about this, right? Try anywhere. I am picking up this box, 8 and 3 and a single star. What does this 3 mean? That means all these 3 bags are more than 5. Now think about that for a second. If all are more than 5, that means here you could have 6, 7, 8, 9, here you could have 6, 7, 8, 9 in obviously increasing ascending order depending on how you want to organize it. But all 3 bags are more than 5. Can the minimum be 1? If I'm looking at this data, can the minimum be 1? And what am I doing? There is a single star here. I'm checking out which rule can work for me. This rule cannot work for me for this particular story, right? Again, the median is 8, so even this rule is not going to work for me. That means this is the rule that is working for me. That means the third bag is going to have 9 coins. And again, boom, you're almost done with this, figuring out this box as well. 9 plus 8, 17. Here you can take a value from 6 to 9. The only value that will work is 7, because 17 plus 7 will give you a total of 24, which is a multiple of 3. That means once you divide it by 3, you will get an integer, right? So what am I doing? I'm just trying out, I'm trying to get comfortable with these rules, so that once and initially some slow speed is okay, because once I master it at how to play this game, then applying it over and over again, box after box, is going to be fairly straightforward. And in fact, what you should ideally do right now is hit pause, because I've shown you how the game is to be played. Now you get into the game and play it by yourself, because that's where the real muscle development, mental muscle development will happen. That's I have said like 150 times earlier, right? So I hope you do that, but otherwise let's continue with the story. So to simplify it, I just kept the rules in front of me. I remember the sum is 45 each row, 45 each row, and the sum is 45 each column as well. All of this will come in handy. And this I've already figured out. This is 9, 9 and 3. The sum is 21. This also I figured out. This is 9, 8 and 7, and the sum is 24. Why am I looking at the sum as well? Because now in any other box, this 21 and 24 story cannot work for me, right? And I have figured out how to play the game, so I can pick up any of the boxes and start playing. Let me look at this story. The median is 2. 2 of the rules are being met. The median of the coins is 1. Obviously is not working here in this particular story. I'm looking at this box and this box. 2 rules are working, but the median rule is definitely not working. That means the other 2 rules are working. That means this is 1, minimum is 1, and the maximum is 9. Wow, such speed here, right? 9 to 11 and 1, 12. And this is when you are in the fun zone category. You will already feel an excitement and a rush. Okay, now I can figure out most of the stuff here. It will require some effort, some calculation, maybe some trial and error, but the fundamental logic is already in my pocket, right? Now a couple of things here. The 24 and 12 give you a total of 36, and you know the overall total is 45, so this sum has to be 9. Now go in this direction. 21 plus 9 is 30. That means the sum here is going to be 15. Okay. Play with this story. The median is 6 and 2 bags are more than 5, and there is a single star here, right? One of the rules is being met. 2 bags are more than 5, that means the other bag can be from 6, 7, 8, 9. One rule, the median is 6. Once again, this rule is definitely not working for me. It could be that maybe this is the rule. Now this is where I get into trying the story out. Maybe this is the rule, it would be 1. And then it becomes a game of adding things together. 6 plus 1, 7. You want a total of 15, so this would be 8. This could be a story. It matches my 15 story very clearly. But maybe this is my rule. I have one rule working. This is my rule. That means my highest is 9. So you have 6 and 9. But 6 and 9 is already 15, and you have a bag empty still. You still have to put some value there. So this story is not going to work for me. And I get to again I get to a fixed answer of 1, 6 and 8, right? I want to try a little experiment here. This is just for bonus. You can skip the next 2-3 minutes and continue with this story, or you can again hit pause and just keep playing the game and you'll figure out everything. But let's say if I do not have this 45 going for me, can I still figure out one of these situations, right? So I'm assuming I do not know this 45, I do not know this 45. I did not think that systematically in the beginning. That means I haven't figured this out as well. I know it is going to be something, some value here, right? And let's say I haven't figured out this story as well. These two I had already figured out, 24 and 12 I had figured out. I'm not using the 45 data anymore. This is just a small demonstration that even if you did not figure out 45 in the beginning, after a bit from some other direction, you'll figure it out, right? Again, stay with this story. Two bags which are more than 5, that means 6, and the other bag will be more than 5, that means 6, 7, 8, 9, etc. One of the rules is being met. It can't be the median because the median is 6, so this rule is definitely not working. Maybe the minimum is 1, so this is the story. 1 plus 6, 7. Now, I do not know this value, nor do I know the total to be 15. That was a separate story, I'm forgetting that. But I am at a sum of 7, 1 plus 6 is 7. The other numbers could be 6 or 7 or 8 or 9. The only number that works to make a multiple of 3 is 8. 7 plus 8 will give you 15. 7 plus 6 will give you 13, which is not a multiple of 3. 7 plus 7 will give you 14, not a multiple of 3. 7 plus 8, yes. 7 plus 9 will give you 16, which is not a multiple of 3. So you're left with this 168 story only. So you will get 168. But that was when I'm assuming this rule to be working. What if this is the rule? That means the other story could be this is 6 and this is 9. 6 and 9, 15, and the other will have to be at least 3 to make a multiple of overall the sum to be multiple of 3. So it could be 168. Let's say you did not solve anything and you started into this box directly. You will say it is 168 or 369 according to the checking of conditions, right? Now how do I decide what the sum is going to be? The hint is here. This sum and this sum is going to be same. And observe this for a second. That means y plus this value or y plus this value is equal to each other. Y plus a plus b is equal to y plus c plus d. You will figure out that a plus b is equal to c plus d. That means the sum here, 24 plus 12, is going to be the sum here. So you have 21, this will have to be 15. That means this story will not work for me, right? So I'm not using the 45 story. I'm still using that the sum of the rows and the sum of the columns are equal to each other. And I'm saying, okay, then this two boxes ka sum and these two boxes sum is going to be identical, and therefore this has to be 15 because the total here is 36, right? So even without the 45 story, I have come to a definite conclusion here. What about this? Not using the 45 story, right? 1 star star. What does that tell me? That there is only one bag which is more than 5. Like the highest bag is going to be more than 5. And there are two rules being met. Two possible, and there are two rules being met. So let's play with that. Let me clear this previous data. So maybe the two rules are the first two rules. The minimum is 1, and the median is also 1, right? 1 plus 1 is 2. The third number has to be more than 5. That means 6, 7, 8, 9. Once again, the only number which will fit here, is going to be 7. So 1, 1, 7, 7 plus 1, 8 plus 1, 9. This could be a possible story, which I already know it is the right story because the sum is 9. But I experimented and I said maybe 117 is a story. But are these two the only possible rules? What if the minimum is 1 and the maximum is 9? These are the two rules. So let me try it again. 1 is the minimum, maximum is 9. The middle set we do not know. Again, think of the sum. 9 plus 1, 10. If you put a 2 here, you get to 12, which is a multiple of 3. But can you put a 2 here? No, because the 12 number, the sum of 12 is already taken care of. So you cannot have a 2 here. Now, you can try putting a 3 or a 4 or a 5 because remember you cannot go more than 5. There is only one bag which is more than 5, which is 9 here in this case. You try out 9 plus 1, 10, you add a 3, it will not work. You add a 4, the sum will be 14, it will not work. You add a 5, 9 plus 1, 10 plus 5, 15 might work, but again 15 is also taken care of. So this 1 and 9 story, this rule and this rule together is definitely not going to work for me. What about using these two rules? And now this is interesting, you will see a problem here. The medium of the number of coins is 1, so the middle term is 1, the maximum is 9. If the middle term is 1, the first term will also have to be 1, just like the story was playing out here. If the median is 1, you cannot have 0 obviously, you should have either lower value or you can go to an equal value. So it will be 1 here, right? So now in that case, if I have a 1 and 1, both the rules are being met, right? That means all three rules are being met. But you're not getting to a multiple of 3, so even this story is not going to work for me, it is cancelled out. So finally I'm left with a 117 story only, which means the sum is 9, which means now that the sum is 45, and again the sum is 45. Now I have figured out that 45 from another direction, right? So a little detour just to show you that no matter what direction you take, you will get to the answer. And now we are almost done with mastering the process. Now it's going to be very, very fast to figure out the rest of the story. Pick out any of the boxes, and again, your order might be different from my order, but because you have things locked down, no matter which direction you take, you'll eventually come to the final solution. So choose randomly. Let's say this 2 star star, 3 bags here. 2 of them are more than 5, right? It's going to be 6, 7, 8, 9 here, 6, 7, 8, 9 here possibly, and one of them is less than 5. Okay, so let's start playing with the conditions again. Two rules are being met. Maybe these are the two rules, right? That the median is 1 and the minimum is 1. But for a minute, notice that if the median is 1 and the minimum is 1, you said there are 2 bags which are more than 5. In this story, there will only be 1 bag which is more than 5. So these two rules working together is not going to work for me, right? What about these two? Rule number 2 and 3. The median is 1. Again, the same problem, because I have seen it already once. If the median is 1, the lowest is also going to be 1. Once again, the same problem. There have to be 2 bags which are more than 5. That condition is not being met. So this is not going to work for me. These two rules together does not work for me. That leaves me with this rule and this rule. That means the minimum is 1 and the maximum is 9. The minimum is 1, the maximum is 9. And the possible values for the middle bag is 6, 7, 8, 9. So 9 plus 1, 10, 10 plus 6, 16, not a multiple of 3. 10 plus 7, 17, not a multiple of 3. 10 plus 8 will work for me. So wow, I figured this out. 9, 10 and the sum is 18. The moment you figure this out, a couple of things happen. 21 plus 18 is 39. That means the total for this is going to be 6. 24 plus 18, the sum is 42. The total is 45. I know the row total is 45. That means this will have to be 3. If this is 3, it has to be 1, 1, 1. You could have come to this 1, 1, 1 using this rule as well. Maybe you did not start with this box. Maybe you started with this box and you figured out 1, 1, 1. Then you would say 24 plus 3, 27. This has to be 18 and figure out the story, right? And actually, I will pause here just to reduce the size of the video and say figure out the rest of the story for yourself. Some effort must be made by you. I will assume that in the next frame onwards, I will have the table full already, but please work it out for yourself only, right? I'm assuming some effort now you can put in and figure out the values. Maybe this will require, again, 15 plus 3, 18. That means this has to be 27. That means this has to be 9, 9, 9. Now things happen very, very quickly, right? And follow your own directions as well. And then tomorrow try the problem out again, because then somebody else tells you the solution, it seems very good. After a day's break, try it out again. Try it from different directions, because you are trying to master the process, not this particular set. You're saying, can I go from any direction and figure out the logic and check the rules over and over again. So a very simple set. The key here is repetition over and over again. That means you do need some mental stamina. You need focus for like 10, 15, 12 minutes. So that is the challenge here. Not like some big intelligence, formula, integration, differentiation. No rocket science here. Commonsensical things, but repeated infinite number of times, right? Check the thing out. So I had probably left only one box anyway. So this is my final scenario. The sum is 9, the sum is 12, the sum is 24, the sum is 21, the sum is 6, the sum is 18, the sum is 15, the sum is 27, and the sum is 3. Now connect it to your beginning story. All are multiples of 3, all give you distinct average integers as such. We are done with the story. What is the total number of coins in the boxes in the third row? In all rows, the number of coins is the same, and the answer is going to be 45. Now, some people could have figured this out 45 very, very early from the very first rule. Some people could have figured out after figuring out this vertical and this horizontal without using the first rule. But in any case, this 45 gets figured out reasonably early in the story. So maybe you can mark this question earlier than others, right? How many boxes have at least one sack containing 9 coins? At least one sack containing 9 coins. This box will work for me. This box will work for me. This box will work for me. This will work for me. This will work for me. 1, 2, 3, 4, 5. My answer is going to be 5. So the effort is already done. Now it's just easy cruising. In fact, I will leave the questions to you. Let me try any one random one. How many sacks have exactly one coin? This sack, this sack, this sack, this sack, this sack, this one, and these 3. Now count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many sacks have exactly one coin? 9 sacks, right? So try out the rest of the questions by yourself. There is not too much of a challenge. Maybe this requires a little bit of effort. How many boxes are the average and median of the number of coins contained is the same. The average is going to be 9. The total is 9. The average is going to be 3. But the median is 1. So this is not fitting my criteria. But this one, the average is 2. 3 plus 2, 5 plus 1, 6 divided by 3. The average is 2. And the median is 2 as well. So the median and average are the same. So this will work for me. Keep checking it for the rest of the boxes and figure out the answer. It's not a challenge anymore, right? So I hope this was a lot of fun, and the experience was that anything can be tackled if I dive into it, and do not get distracted from the process. How to figure out the process is the main game here, and that is by using small examples right in the beginning of the story so that your brain is warmed up and ready, trying out a couple of examples, and then boom, the process is in your pocket. Applying it box after box is not going to be too much of a challenge, right? I would not put this in the super easy category because it looks different. A lot of people, I know, the fear factor will just look at this data, star, 2 conditions are being met, I have not seen a problem like this, and etc, etc. So that will come in the way. But that's why I've opened this up fully also, because notice that this is no different from any of your easy problems. It looks scary on the surface, but eventually your basic deductive reasoning, your stamina, mental stamina, focus, concentration is the name of the game here, right? Because otherwise, maths wise or logic wise, it's very, very basic stuff, except the fear factor, that if I'm scared of DILR and I think it's an impossible thing, I don't like it, I don't have a healthy relationship with, obviously it's going to be difficult. So I hope you try out more problems by yourself, even if it takes a day or 2 or 4 hours, 5 hours, it's fine. Keep looking at it, keep trying, because you know everything gets solved. After 30, 40, 50 videos of learning, you've seen that everything gets solved. So you try and figure out by yourself, only because you're also a human being, you have the same brain as I do or as a DILR genius. And the genius will come when you force it, you bang it against the wall, then finally the sum, everything works out. And that's the magical feeling that we are trying to chase. That joy is actually a chemical release in your body, because you had a task, it took a day, but you figured it out, and wow, right? That's expensive dopamine. It is not like looking at Instagram and feeling, oh wow, I'm feeling good. It has better value than the cheap dopamine, right? So I hope you're getting the required passion involved to tackle such things, and I hope you keep at it. I will see you very soon in the next challenge.